This is the test that we have made in the case study in Portugal, Campina de Faro, Algarve, rehabilitating the river basin that we had in the riverbed. And in the Gabardine project, this basin is 100 square meters, 20 meters large, 5 meters wide and 7 meters depth. The use was to clean the top of the aquifer that was impervious, so that the water could penetrate directly to the sands in unconfined aquifer. So in MARSOL project, what we have done with the team of Lenec, of TAR, this is Tiago, this is University of Algarve, this is Lenec, Teresa Leitão, and we have here the partners that have provided us with the pump, and the pump is putting 18 cubic meters per hour, and so we have put this 18 meters since today, 1st of July 2014, and we started dripping the water 18 cubic meters per hour on the basin. We have a well point there where we have the scale, and we have measured the water increases in height, so reducing the depth. The water table was minus 5 meters, and it took us 6 hours to reach the ground. From there we increased this 20 centimeters, and we kept almost 5 cubic meters per hour. That corresponds more or less to 1.2 meters of groundwater recharge, managed aquifer recharge in this area. We are going to show you, Tiago Carvalho is going to show you the diver that we have measured there, where we have tried to fit. So now we have 2 water dividers, so the 18 cubic meters per hour, one part, that's almost 5, 4.8, around 5 is going to the basin, and remaining is going to the riverbed rejected downstream. To calibrate, we have used a 200 liters vessel that we have on the bottom, and then we are measuring until we could stabilize this. Besides that, we have made a clogging test, trying to see the increased water in the basin, in the well point, and we have detected almost, but we have to be certain to see the diver logs afterwards to see, but from 7 years we think that the basin is absolutely clean, and the amount of water infiltrating is the same as in May 2007 in the same type of essay that we have made in Gabardine project, demonstrating this is useful to use the water flowing as surface water in the river to put in groundwater, so that in wet years you can transfer the water through managed aquifer recharge to be used later, eventually in dry years.
This is the tube where the water flows out. Some detail about the basin soil. And now we have some CTD divers inside to measure conductivity, pH and piezometric level in the basin. This is the wall that we have constructed, provisional wall to sustain the water and to do the experiment, the clogging experiment. Now we are measuring the outflow water, so the amount that is being rejected to the river. And the basin we are now stopping the test, the infiltration test that we have done for a full day, and we are going to measure the amount of water recuperation in the wells. And these are the type of probes that we are using, not only in the basin itself to check out the water level. So these are CTD divers for conductivity, temperature and depth. And these are not only in the basin itself but also in the wells that are monitoring the results, regional influence.
Now, after stopping, we are measuring how long does it take for the 20 centimeters to go into the soil.